6th grade, Module 2, Lesson 17, Classwork. Opening exercise. Below is a list of 10 numbers. Place each number in the circle that is a factor of the number. Some numbers can be placed in more than one circle. For example, if 32 were on the list, it would be placed in the circles with 2, 4, and 8 because they are all factors of 32. Okay, so before we do this, I think it makes more sense to go down here to the discussion part and go over the divisibility rules for each number. So if a number is divisible by 2, the rule is that it ends in 0, 2, 4, 6, or 8. And another way to say that ends in would be saying the unit digit. So it ends in, or the unit digit in, I guess we don't need to say is, an even number. So 0, 2, 4, 6, or 8. So if we wanted to go up here and find any of these numbers that are divisible by 2, we're just looking for anything that ends in 2, 0, 2, 4, 6, or 8. So if we see 24, for example, that ends in 0, 2, 4, 6, or 8. So it's divisible by 2. So 24 goes in there. 36 ends in 6. So that goes in there. 80 ends in a 0. 115, that ends in a 5, so it's not divisible by 2. 214 would go in there. 360. 975, 5 is not an even number. 4,678, because 8 is an even number. 29,785 would not go in there because 5's odd, and 414,940 would belong in there. So it ends in a 0. Okay, on to 4. So the divisibility rule for 4 is that if the last 2 digits are a number divisible by 4. So we'll say if the last 2 digits are divisible by 4. So just meaning if we can evenly divide the last 2 digits by 4 and get a number. So 24, the last 2 digits, the whole number is 24. It only has 2 digits. So 24 divided by 4 is 6. So this is divisible by 4. 36 divided by 4 is 9. So this is divisible by 4. 80, we can do 80 divided by 4, we get 20. So now, 115, the last 2 digits are 15, and 15 is not divisible by 4. So 115 would not belong in there. 214, so the last 2 digits are 14. 14 is not divisible by 4. 360, 60 is divisible by 4, it'd be 15. So 360 does belong in there. 975, we cannot do 75 divided by 4, so that does not belong in there. 78, I'm honestly, let's do 78 divided by 4. Let's see if it works. 4 can't go into 38, so that's not going to work. That's not divisible by 4. 29,785. 85 is not divisible by 4, and 40, the last number, 414,940, 40 divided by 4 is 10, so this does belong in there. Okay, 5. So the divisibility rule for 5 is that it must end in a 0 or 5, or the unit digit is 0 or 5. So I like 5 because all you have to do is look at the last number. If it's not 0 or 5, then it does not belong there. So we're just looking for anything that ends in a 0 or 5. So that would be 80, 115, 360, 975, 29,785 and 414,940. Okay, 8, the divisibility rule for 8. If and only if the last 3 digits are divisible by 8. So this time we're looking at the last 3 digits and need to decide if that is divisible by 8. Okay, so let's look at what we have. We have 24. So if a number only doesn't even have the last 3 digits, we just look at whatever it is. So 24 divided by 8 is 3, so 24 works. 36 divided by 8, we can't do 36 divided by 8. We wouldn't get an even or a whole number. 80 divided by 8 would be 10. That works. Okay, so 115 divided by 8. We cannot do 115 divided by 8. 214 divided by 8. I'm honestly not sure, so 8 is my least favorite divisibility rule because it requires the most work. So we might have to do some division problems here. So 214 divided by 8. 8 goes into 21 twice. 54. 8 goes into 54. Let's see, 8 times 7 is 56, so it can go in 6 times. So it's going to have a decimal, and we're going to have a remainder. We're going to have to keep going, so it's not a whole number. So that does not go into it. The good news is if we figure out that it's not a whole number, we can just quit doing the problem and move on. Okay. 360. So 360 divided by 8. We can do, let's try it. So 8 can't go into 3, but it goes into 36 4 times. 40, 8 goes into 40 5 times. So 45, it does. So this 360 is divisible by 8. 975. Let's see. 8 goes into 9 one time. 8 goes into 17 twice. 8 goes into 15. Twice would be 16, so only once. And our decimal point is going to be right there. We have a remainder and we have to keep going. So it's going to have a decimal. So I'm just going to move on. 4,678. So here's where we get to the point where we only have to look at the last 3 digits. So we're just looking at 678. So I'm going to do 678 divided by 8. 8 can't go into 6, but it could go into 67. Let's see, 8 times 8 is 64. 8 goes into 38. See, 8 times 5 is 40, so it can only go in 4 times. That's 32. We have 6, and I have to keep going. I'm going to have a remainder, so it cannot go into that evenly. Let's try 29,785. So we just have to work with 785. 8 can't go into 7, but it could go into 78. Well, 8 times 10 is 80, so 9. 8 times 9 is 72. 65, 8 goes into 65 8 times, because 8 times 8 is 64. 1, and we're going to have to keep going, which means we're going to have a remainder, so that one doesn't work either. And 940. 8 goes into 9 once. 4, 8 goes into 14 once. Bring down the 0. 8 goes into 60 7 times. That's 56. We're still going to have a remainder, so that does not go in evenly. So the only ones that go in that are divisible by 8 will be 24, 80, and 360. And then my favorite one, 10. So the rule for 10, divisibility rule for 10, is if The unit digit is 0, so it just has to end in 0. Or if we want to be more technical, we can say unit digit is 0. So anything that ends in a 0, which would be 80, 360, and 414,940. Okay, so there they are. Now, what we're going to work on are the divisibility rules for 3 and for 9. So let's work on discovering the divisibility rules for 3 and 9. So the divisibility rule for 3 is that the sum of the digits are divisible by 3, and the divisibility rule for 9 is that the sum of the digits are divisible by 9. So all you have to do is add up the digits and see if they're divisible by 3 or 9. So we're going to explore this a little bit more and show why that works. So try and stick with me. This is a little bit confusing, but try and stay with me. Okay, so example 1. This example shows how to apply the 2 new divisibility rules we just discussed. So for 3 and 9. Explain why 378 is divisible by 3 and 9. So the first thing we're going to do is expand 378. So writing it in expanded form like we learned in 5th grade. So that would be like 300 plus 70 plus 8. Or if we really want to expand it, we can say 3 times 100 plus 7 times 10 plus 8. We could do 8 times 1, but we'll just leave it as plus 8. Decompose the expression to factor by 9. So what we're going to do is decompose the 100 and the 10 to bring out things that are divisible by 9 so that we can factor them out, meaning kind of like bring them out so that we can eventually just kind of get rid of them. So when I look at what we have 110 that we're trying to kind of factor out or decompose into 9 or factors of 9. So 100, I'm going to break into 99 plus 1 because we know that 99 is divisible by 9. So I'm going to change it into 3 times 99 plus 1 plus 7 times 10. I'm going to break into 9 plus 1 plus 8. And so if we wanted to kind of simplify that, we could have 3 times 99, and then this 3 times 1 just will be plus 3, plus 7 times 9, plus that'll just 7 times 1 is plus 7, plus 8. Okay, now it says factor the 9. So what that means is we're just going to bring out any 9s that we can, bring them to the forefront. So I'm going to keep factoring out the 9. By 99, I can break that into 9 times 11. So I'm really trying to factor out the 9, bring out any 9s that I can. So 3, I'm going to turn it into 9 times 11 plus 3 plus 7 times 9 plus 7 plus 8. And now I'm going to do, by factoring out the 9, we have 9 times 11, and we have a 9 right there. So I'm going to switch the order around, and we have 9 times, so we have here 3 times 11, and this was plus 7 right here. So I'm going to add plus 7, and then I'm just going to add the 3 and the 7 plus 8. So I really just reworked the problem, but it's the same problem. I just factored out the 9. What is the sum of the 3 digits? So notice how once we factored out the 9, this part right here, so we factored out the 9, what we're left with is 3 plus 7 plus 8. So we know the reason that we did all of this is because we now know that all of this part is divisible by 9 because we're multiplying it by 9. So what we're left with is 3 plus 7 plus 8, which if you remember, we started with 378, right? Yeah, we started with 378. So when we factor out the 9, we get 3 plus 7 plus 8. So what's the sum of the 3 digits? 3 plus 7 plus 8. 3 plus 7 is 10, plus 8 is 18. So is 18 divisible by 9? Well, 18 divided by 9 is 2, so yes. Is the number 378 divisible by 9? So we would say yes, because the sum of the digits is divisible by 9. Yes, because the sum of the digits is divisible by 9. Is the number 378 divisible by 3? Why or why not? So there's 2 reasons why it is. Number 1, because 3 is a factor of 9, so anything that's divisible by 9 is also divisible by 3, but also because the sum of the digits 18. 18 divided by 3 is equal to 6, so the sum of the digits are divisible by 3. I didn't say yes. Yes, the sum of the digits is divisible by 3. So anything that's divisible by 9 is also going to be divisible by 3. Okay, example 2 is 3,822 divisible by 3 or 9. Why or why not? Okay, so we're not going to do that long, broken down, factoring out explanation. All we're going to do is add the sum of the digits. So 3 plus 8 plus 2 plus 2. So 3 plus 8 is 11, plus 2 is 13, plus 2 is 15. So 15 divided by 3 is 5. So yes, it's divisible by 3, but 15 divided by 9 is, that doesn't work. We're not going to get a whole number. So divisible by 3, but not by 9. And then, this is kind of our explanation right there. If you want to write out more of an explanation, you can. Exercises 1 through 5. Circle all the numbers that are factors of the given number. Complete any necessary work in the space divided. Okay, so 2,838. So we have 3, 9, and 4. Let's start with 3 and 9. So we're going to add the sum of the digits. So 2 plus 8 is 10, plus 3 is 13, plus 8 would be 21. So can we do 21 divided by 3? We get 7, so yes, it's divisible by 3. Can we do 21 divided by 9? 21 divided by 9, we can't do. So it's not divisible by 9. And then to find out if it's divisible by 4, we take the last 2 digits. 38 divided by 4. Nothing divided. We can't get a whole number, so that's going to be a no. So explain your reasoning for your choices. So this, start with 3. So the sum of the digits which was, we'll just say 21, was divisible by 3, but not by 9. And then we'll say the last 2 digits, which was 38, was were not divisible by 4. $34,515 is divisible by 3, 9, or 5. So just looking at it, it ends in a 5. So I know it's divisible by 5, because if it ends in a 0 or 5, it's divisible by 5. So let's work on 3 or 9. So 3 plus 4 plus 5 plus 1 plus 5. So this is equal to 11. And that's 3 plus 7, or 3 plus 4 is 7. So 7 plus 11 is 18. So we can do 18 divided by 3 is 6, and 18 divided by 9 is 2. So it's divisible by 9 and 3 and 5. So we can say the sum of the digits is divisible by 3 and 9. And we can say the unit digit is 5, so it's divisible by 5. Number 3, 10,534,341 is divisible by 3, 9, and 2. So I'm going to start with 2. So in order for it to be divisible by 2, it needs to end, the unit digit needs to be 0, 2, 4, 6, or 8. And it's not, it's 1. So it's a no for 2. I'll just go ahead and write that down. Not divisible by 2. Because the unit digit is not 0, 2, 4, 6, or 8. Now let's check on 3 and 9. So we're going to have to add all these digits. 1 plus 0 plus 5 plus 3 plus 4 plus 3 plus 4 plus 1. So let's do it a little bit at a time. So we have 6 plus 7 plus 7 plus 1. And then we'll have 13 plus 8. And 13 plus 8 will be equal to 21. So the sum of the digits is 21, meaning that we can do 21 divided by 3 and we get 7, but 21 divided by 9 we can't do. So it's divisible by 3 but not 9. So the sum of the digits 21 is divisible by 3 but not 9. Number 4. 4,320 is divisible by 3, 9, and 10. So let's start with 10. In order for something to be divisible by 10, the unit digit needs to be 0. And here, the unit digit is 0, so it's divisible by 10. So we can say divisible by 10 because the unit digit is 0. Now let's try 3 and 9. So 4 plus 3 plus 2 plus 0. 4 plus 3 is 7 plus 2 is 9. So we can do 9 divided by 3 is 3, and 9 divided by 9 is 1. So it's divisible by 3 and 9. So the sum of the digits is 9, and 9 is divisible by 3 and 9. Number 5, 6,240 is divisible by 3, 9, and 8. So let's start with 3 and 9. 6 plus 2 plus 4 plus 0. 6 plus 2 is 8 plus 4 is 12. So we can do 12 divided by 3. We get 4, but 12 divided by 9, we don't get a whole number. So it's divisible by 3, but not 9. Because the sum of the digits is 12, and 12 is divisible by 3. Okay, remember the divisibility rule for 8 is that the last 3 digits are divisible by 8. So 240 divided by 8. So we could look at this as 24 divided by 8. 24 divided by 8 is 3. So 240 divided by 8 would be 30. So it's divisible by 8 and 3. So it's divisible by 8 because the last 3 digits are divisible by 8.